This is a video on velocity, acceleration, tangent, and normal vectors. The question states, find v of t, a of t, t of t, and n of t at t equals 1 for the vector-valued function r of t is equal to 2ti plus t squared j. So first let's find the v of t, which is the velocity, and that is the derivative of r of t. So we take r prime of t, the derivative of 2t is 2, and the derivative of t squared is 2t. So I get 2i plus 2tj. To find a of t, that's the second derivative of r of t, which is the derivative of the velocity, or r double prime of t, and the derivative of 2i plus 2tj is just 2j. So let's find capital T of t, which is the unit tangent vector, and that is equal to r prime of t over the magnitude of r prime of t. So r prime of t was 2i plus 2tj, and the magnitude of r prime, I just take the square root of the sum of 2 squared, or 4, plus 2t quantity squared, or 4t squared. I can simplify this. I can factor out a 4 and pull it out as a 2, and then cancel each of these 2's, and then split up this fraction and write it as 1 over the square root of 1 plus t squared I, plus t over the square root of 1 plus t squared j. And there's my unit tangent vector at time t. So there's various ways of finding the unit normal vector. In 2 dimensions, I can find the unit normal vector by finding an orthogonal vector by just switching the I and the j components and making one of them negative. I could figure out which one is negative by sketching a picture. I know that r of t is a parabola since it's 2ti plus t squared j. So it also goes from left to right because as t increases, x increases. So the unit tangent vector points upwards like so, and the unit normal vector always points inside the curve and orthogonal to t. So that means that the I component of the unit normal vector is negative at t equals 1, and the j component is positive. So I can just switch the I and the j and make the new I component negative. And I get the normal vector is equal to negative t over the square root of 1 plus t squared I, plus, and then 1 over the square root of 1 plus t squared j. So I'm almost done. I'm asked to find these vectors at the value t equals 1. So I just plug in 1 to each of these. So if I plug in 1 into the velocity vector, I get that v of 1 is 2i plus 2j. If I plug in 1 into the acceleration vector, I just get that a of 1 is 2j. And if I plug in 1 into the unit tangent vector, notice that the square root of 1 plus 1 squared is the square root of 2. So I get that t of 1 is 1 over root 2i plus 1 over root 2j. And then finally the normal vector, I plug in 1, and I get that the unit normal vector evaluated at t equals 1 is negative 1 over root 2i plus 1 over root 2j. And I'm done with the problem.